Let's explore complex numbers, which extend the number system beyond what we typically think of as real numbers. At the heart of complex numbers is the imaginary unit I, defined as the square root of -1. That is, I equals square root of -1. Consider the equation x squared equals -1. If we only consider real numbers, there's no solution because no real number, when squared, results in a negative number. So what is x? To solve this problem, we introduce the imaginary unit, denoted by I. By definition, I is equal to the square root of -1. The imaginary unit solves our problem. The imaginary unit, I, has some unique properties. First, I squared is equal to -1. Second, I to the power of 4 equals 1. This creates a cyclic pattern when raising I to different powers. A complex number z is defined as z equals a plus bi, where a is the real part and b is the imaginary part of the complex number. Complex numbers can be visualized on a complex plane. The horizontal axis represents the real part, while the vertical axis represents the imaginary part. Thus, a complex number is represented as a two-dimensional point with coordinates a and b. Complex numbers can undergo basic arithmetic operations. For addition, if you add two complex numbers, a plus bi and c plus di, the result is a plus c plus b plus d times I. For multiplication, if you multiply a plus bi with c plus di, you get a c minus bd plus ad plus bc times I. Complex numbers have many real-world applications. They are used in electrical engineering to analyze alternating current circuits and control systems. In physics, they appear in quantum mechanics and wave functions. Finally, in signal processing, complex numbers are essential in Fourier transforms and filtering. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.